So hi everybody. Um, my name is Andreas, and I wish we could have been there at the event in Regensburg, but unfortunately this is not possible. So I'm doing my best to walk you through the joint work of myself with a bachelor student of mine, Dominik, and we did work over the last couple of months, well actually a little bit longer, on a tool to support threat modeling. So threat modeling with respect to designing software architectures. And we experimented with several tools, Microsoft Threat Modeling tool, which was one of the earliest tools in that domain. But we found that we could actually do better. So we developed OWL, which I'm going to give you a quick demo about later on. And then we found that we had to do something about trying to understand on basis of which information we can actually identify threats in a software architecture. And this led up to this work. So we are using threats that we derive from common public and well-maintained repositories. So most notably the common weakness enumeration and the common vulnerability enumeration. And we actually do demonstrate in this paper how we can use a machine learning based text classification approach to perform certain mapping activities between these two data sets into a new data set. So first of all, threat modeling itself is an accepted technique to identify possible design flaws in the early stages of the software development lifecycle. What does it mean? Well, it all has to do with a shift-left approach. So basically, you want to try and understand how you can take care of security already at the design stage. So not at the coding stage, that's way too late, not at the testing stage, or even worse at the deployment stage, because identifying a design flaw or a bug, which are two different things, in the later stages of the software development lifecycle can be really costly. So up to a factor 100 more expensive than actually removing that design flaw or taking care of that design flaw or the bug in, for example, the design or earliest implementation stage. So this idea is not new. We should have been doing this for the last 15 odd years. And actually, Microsoft was one of the leading contributors in that space. So they developed a technique which is called STRIDE. STRIDE is just a mnemonic for spoofing, tampering, repudiation, information disclosure, denial, and elevation of privilege. But the problem is that STRIDE requires an underlying database of threats. Yeah, we actually call this a threat catalog, and this is actually what we derived in our work from these publicly available sources, so the CW and the CVE. So this is what we present, this new type of threat catalog, which essentially is just a combination of CWE and CVE and some clever linking to the STRIDE categories. And since we cannot completely map CWE and CVE as well as map the combined two data sets with STRIDE by means of certain database keys, we can do that for about 60%, but for the remaining 40%, we need to do something else. And we actually suggest to use this text classification approach. And in my talk later, I will demonstrate the integration in our threat modeling tool. So STRIDE-based threat modeling, this is something you need to understand. Core idea, again, kudos to Microsoft here. They've got an excellent tool. It's the Microsoft Threat Modeling tool. It's freely available. And what you can actually do is you can basically try and reduce a complex software architecture down to its most elementary parts. So namely data flow diagram, where you just have an interactor, a process, maybe some kind of data store, we don't see that here, as well as connections between those, and the dotted red lines are so-called trust boundaries. Yeah? And then what Microsoft suggested, or the some engineers at Microsoft and later Adam Shostak was the main, principal investigator here, is they provided us with a table. Yeah, and in that table they basically said, well, if you do have a data flow diagram, and you do have these elements, interactors, processes, data stores, data flows, so any kind of system can be represented by using this kind of technique. Then we suggest that you may want to look at certain possible threats that could arise, yeah, either with respect to a single element itself or with respect to an interaction between two elements. Yeah? So in essence, it's just a very blunt computation. Yeah? So you draw a diagram, you parse it, you create an in-memory representation, and then you just bluntly apply that table and push button, you get a list of possible threats with respect to that architecture. Now, problem is the generated threats are either way too general. So you just get something like spoofing could occur here, or elevation of privilege could occur here, and that's usually not very useful. Or the threats, the reports are very domain specific and proprietary. Yeah, so maybe they relate to Microsoft.NET stack or the Azure stack, and simply we can also not reuse them in our open source approach, which I will present later. So this was actually one of the main driving issues. We wanted to find an alternative which is simply not proprietary to provide the community with a threat catalog. And another issue is too many threats are generated. Yeah, so you got way too many false positives. I did some work like almost 10 years back at ACM SAC, where I actually looked into this ratio of false positives, and it's simply too high. So the idea is, why not use existing repositories that may provide certain information that we could use in combination with the Stride approach and in our tool. And well, we've got this information. So one is the common weakness enumeration, and the other one is a common vulnerability enumeration. And the main difference is the common weaknesses, they just describe potential problems that could occur in the design of your software, yeah? Or potential sources of bugs you could run into. Whilst the CVE is basically a representation of a known concrete exploit. Yeah? So complete difference. Weakness is not yet an exploit, it's just simply there, but maybe nobody's exploited it yet. CVE, a vulnerability that really, where an attacker really created an exploit on basis of a weakness or a bug. The last question we thought about was whether we can actually use these CWEs to provide a different and alternative reduced view on possible threats. And in essence, what we are trying to do is, in our tool, we as in a common database or standard database, we try to provide different views that may help to that may help an architect, a security architect, to understand what issues he needs to take care of when a system goes into development. And you will see a demo later. So what did we do? So first of all, we built a data set out of the CVE and CWE databases. They are publicly available. You do have to do a bit of sanitization and modification to actually align them. And the good thing is there is already, there are certain key values that allow you to go from a CVE to a CWE and the other way around. Yeah. So usually you go from a CVE to a CWE. So you have a concrete exploit memory leak in Microsoft SQL Server, something that will actually go to a CWE, which may actually be a description like never forget to call free after malloc. So the very simplistic example. However, we do not have this this mapping for about 40% of the CVEs. And we needed to find an alternative way. So 60% of the mapping we could just do by standard key mapping techniques. 40% that was simply not possible. And well, we use a certain field in both data structures, which is called common consequences. And this actually helps us. I'm still in the first step here. This actually helps us to map our new data set against stride. Yeah? So these two steps are actually our first two initial steps. So we take CWE and CVE and map them. So we can do that for about 60% of the corpus. We get a new data set, we call that threat catalog, and we map this threat catalog against the stride categories using the common consequences data structure. For the remaining 40%, we use a text classification approach. And the nice thing is we've got a huge body of training data already because we have done that. Yeah? So this basically here is our training data. And to now get the link between CVEs and CWEs for these remaining 40%, we use something which in the machine learning domain is called a text classification approach. I'm not really going into the details here, but it's honestly, it's textbook machine learning. So first of all, we have to do some pre-processing. For example, remove certain stop words. Yeah, you would find these stop words in certain libraries. So NLTK is a Python library with about 150, 160 stop words and or something like that, which simply have no meaning. So we removed these. We then did an evaluation of models, which would be most well suited for actually doing this text classification, doing this mapping between CVEs and CWEs. And the result is we tested that also with respect to mapping against the stride categories. And there is a model which is called LightGPM. So that's simply the one that we did choose. What you can see here in this curve here is how well actually our mapping does perform. So again, bear in mind we've actually already got a huge data set that we can use for training. So where we actually did have the primary keys to do the mapping between CW and CVE. So it comes as no surprise that our text classification actually performs very well. Only for one stride category, it does not perform very well. Yeah? So this is actually, so remember again, it's two steps. Mapping a CVE and a CWE, yeah? And then mapping this new corpus against the stride category. So this is what we are mostly interested in. And you see this curve here for repudiation as a threat is not performing very well. But our assumption is, and this is most likely the case, it's simply because repudiation is also massively underrepresented in the training data set. So there's not enough training data for mapping our new threat catalog against the repudiation threat. I give you a quick demo now so that you get an idea what we are doing. So this is OWL. And as I told you, it's you simply model a system as a data flow diagram. You've got interactors, you've got processes, you've got data stores, and you got data flows. We also got trust boundaries, we don't need them. And if I push this button here, I get an analysis. And what you can see here is the following. It will list you a huge number of threads. This is basically just exercising this mapping table stride against the data flow diagram elements. And you can click on one and it will show you, well, Something an attacker could perform a spoofing attack here, or they could perform a denial of service attack, or let me go later here, tampering attack on these model elements. Actually, that's only these model elements, otherwise it would change the highlighting. Yeah, repudiation you could perform this here, and you see already that's pretty unspecific. You know? So before we did our work, this text classification, this category here simply did not exist. But if I push on this button here, it will give me now data from the CWE and CVE corpus, so from our newly generated threat catalog. Yeah? And this actually can help us to maybe take care of a missing input validation. Yeah? You can also see here the mapping against stride and the estimated impact and the estimated exploitability, which, yeah, for input validation is one of the hardest things you actually need to take care of. Parsing generic input, basically, if you've got unspecified input. Yeah? And one last thing we are very proud of, and which really is a difference to the Microsoft Threat Modeling tool, is this one here. So the CVE button. And you see here the following. We got a huge number of CVEs here. And if we push the button here, it says Nginx before version something, blah, blah, blah. It's got the following CVE score, 7.5. That's a median. Yeah? So why do we know which vulnerabilities could occur? Well, reason is each of the model elements can be associated with certain attributes. And actually, the process element here is associated with already a known deployment technology. So at design time, we know already how this piece of software will be realized using a load balancer, Nginx. And by means of that, we can actually query for existing vulnerabilities. We've got a huge number of other attributes here, and these attributes here, you see one, I did choose one, requires authentication. And this is basically the link to our new threat catalog. Yeah? So by just pushing this button here or selecting this field here, requires authentication, we do make the link to our new generated corpus of data. Yeah? And that's basically it. And if you, well, it's, you really ask me, we are very proud of this work because first of all, we think we have done a new sort of relatively fresh design approach to modeling, systems modeling. We can model design artifacts, so we can basically look at possible security weaknesses or weaknesses, design flaws in general, but also we can make that link to known real-world exploits. Yeah? And last thing, we did actually choose an open API approach. So our interface is a Swagger-based interface, and you can actually, and we have done that, you can transfer data from this tool here into, for example, project management tools, into, for example, vulnerability scanners like Nessus, and so on and so forth. And I invite you to actually have a look at this and maybe use it for your teaching. So it's available here under this resource here. It's open source. And with respect to this text classification approach, you find our complete Jupyter notebook also in our GitHub. And in summary, what did we do in this piece of work here? So one major problem with tools like the Microsoft Threat Modeling tools is the underlying threat catalog is proprietary to Microsoft. We cannot use it, but we want to give something to the open source community. So we use CW and CVE to generate such a threat catalog. So we mapped in the first step CW against CVE, where primary keys were available for this mapping. And where these were not available, we used a text classification approach. And lastly, not only did we match CW and CVE, but also this newly generated corpus, we did match it against the 6 stride categories. Yeah? And this is basically what this paper here is about. You roughly see the distribution between the striped categories and where there was a mapping by means of primary keys, and where we basically had to complete that mapping by means of the text classification approach. And as I did show you in the OWL tool, you can now use it to really follow a secure by design approach and identify flaws in software architecture, security flaws or design flaws, which may actually lead to security related exploits as early as possible. And that's basically what we all want to achieve. We use it for teaching at our bachelor's and master level. Do have a look at our GitHub. You can also have a VM or a Docker image. If you're interested, just let me know. So here's the information. And again, kudos goes to Dominik. As far as I know, I've not been that long at that faculty, so it's my third year now. But we are the first where a bachelor student actually managed to get a paper accepted at an international peer-reviewed conference. And with that, thank you very much. And I do honestly hope we all meet soon again in the real world. And stay safe wherever you are. Bye-bye.